Hello everyone and welcome all of you to this online platform. In previous class we have discussed about operations of sets. Today in this class we will discuss law of algebra of sets. So let's start our class. Of sets. Number 1, idempotent law. Idempotent law. When is set A for any set A, we have number 1, A union A is equal to A. Number 2, A intersection A is equal to A. Idempotent law, for any set A, we have A union A is equal to A and number 2, A intersection A equal to A. We take an example. A is equal to, A is a set of the elements 1, 2, 3 and then A union A is equal to 1, 2, 3 and union A 1, 2, 3. আমি আগৰ ক্লাছত কি পাইছো আমি A যদি দুটা সেটৰ যদি আমি ইউনিয়ন উলিয়াও A ইউনিয়ন B তেতিয়া আমি কোনখিনি এলিমেন্ট লিখিব লাগে A আৰু B থকা গোটেইখিনি এলিমেন্টে যেটো আমাৰ সেট ফৰ্ম কৰিব হেতু হৈছে A ইউনিয়ন B এতিয়া আমি দুইটাতে থকা এলিমেন্টখিনি কি পাম এতিয়া কি লিখিম 1 2 3 ইয়াটো কি আছে 1 2 3 এটা এলিমেন্ট আমি কি কৰিব নোৱাৰো ৰিপিট কৰিব নোৱাৰো একাৰণে আমি এলিমেন্টখিনি কি পালো 1 2 3 this equal to A. The first point, hence A union A is equal to A. Number 2, A intersection A. A intersection A is equal to 1, 2, 3 intersection 1, 2, 3. এটা intersection আমি কি পাইছিলো A intersection B এটা কি পাইছিলো আমি কমন এলিমেন্ট যেখিনি কমন এলিমেন্ট খিনি যেটো আমাৰ সেট ফৰ্ম কৰিব হেতু হৈছে আমাৰ intersection A intersection B ইয়াত আমাৰ কমন এলিমেন্ট কি আছে ফার্স্ট সেট কি আছে 1, 2, 3 সেকেন্ড সেট কি আছে 1, 2, 3 তা আমি এলিমেন্ট খিনি কি পাম 1, 2, 3 this equal to A. Therefore we have A intersection A union A is equal to A and A intersection A is equal to A. Next point, identity law. Remember, A union A is equal to A and A intersection A is equal to A. এটা সেটক এটা যদি যিকোনো এটা সেট যদি তাৰ নিজৰ লগতে আমি কি কৰো ইউনিয়ন কৰো এটা কি হ'ব সেই সেটটো হ'ব আৰু যদি একেটা সেটৰে নিজৰ লগতে যদি আমি ইন্টারসেকশন কৰো কি হ'ব তাৰ ৰিজাল্টটো সেই অৰিজিনাল সেটটো আমি পাম নেক্সট নাম্বাৰ 2 identity law. Identity law. For any set A, we have phi and U. Phi means null set and U means universal set as identity elements for union and intersection respectively. Identity law. For any set A, we have phi, null set and universal set, phi and u as the identity elements for union and intersection respectively. That is A union phi, that is A union phi is equal to A. Number 2, A intersection u means universal set is equal to A. That is A intersection A লগত যদি আমি নাল সেট এটা যদি ইউনিয়ন কৰোঁ সদায় কি পাম A সেটটোৱে পাম আৰু A লগত যদি এটা ইনভাৰ্সেলটো যদি আমি ইন্টাৰসেকশন কৰোঁ তেতিয়া আমি কি পাম আমি সেট A টোৱে পাম For example, A is a set of the elements 1, 2. Then A union phi means null set 1, 2 intersection phi is equal to 1, 2. This is equal to A. Next, A intersection U is the universal set. That means A proper subset U. A proper subset U. That is A intersection U is equal to A. Next, number 3, commutative law. For any two sets A and B, we have number 1 A union B is equal to B union A. Number 2 A intersection B is equal to B intersection A. That is union and intersection are commutative. For any sets A and B, we have A union B is equal to B union A, and number 2 A intersection B is equal to B intersection A. That is union and intersection are commutative. For example, A set of element 1, 3. We take same example. B 2, 5, 7. Then A union B is equal to A union B আমি কোনখিনি লিখিম A আৰু B থকা গোটেইখিনি এলিমেন্ট লিখিম 1, 2, 3, 5, 7. Next B union কি লিখিম B A আৰু B গোটেই উমতে আমি কি আছে গোটেইখিনি লিখিম এলিমেন্ট সেম হ'ব 1, 2, 3, 5, 7. Here A union B is equal to this and B union A is equal to this. Therefore A intersection A union B is equal to B union A. Next, number 2. A intersection B. Intersection B means কি? A intersection B means আমি কি কৰিব লাগিব উমহতীয়া মৌল কমন এলিমেন্ট A আৰু B কমন এলিমেন্ট খিনি লিখিব লাগিব কমন এলিমেন্ট কি আছে 2, only 2 তাহলে কি লিখিম 2 নেক্সট B intersection A common element কি আছে B intersection A same 2 therefore A intersection B is equal to B intersection A. The union and intersections are commutative. Next, number 3. Number 4. Associative law. If A comma B and C are any three sets. Then number 1, A union B union C is equal to A union B union C. Number 2, A intersection B intersection C into bracket A intersection B intersection C. Union and intersection are associative. If A and B are any three sets, then A bracket A union B union C is equal to A union bracket start B union C. Number 2, A intersection bracket start B union intersection C is equal to bracket start A intersection B bracket close intersection C. For example, A is equal to 1, 2, 3, B is equal to 3, 4, and C is equal to 1, 4, 7. A union B union C, this is equal to A union B. A union B is equal to 1, 2, 3, 4. 1, 2, 3, 4. Union C is equal to 1, 4, 7. 1, 4, 7. This is equal to 1, 2, 3, 4, 7. Next, this is left hand side. Next, we will find right hand side. A union B union C. A is equal to 1, 2, 3. 1, 2, 3. In union B union C. B union C is equal to 1, 3, 4, 7. 1, 3, 4, 7. This is equal to 1, 2, 3, 4, 7. 1, 2, 3, 4, 7. 1, 2, 3, 4, 7. This and this are equal. Left hand side equal to right hand side. Therefore, A union B union C is equal to A union bracket start B union C. Next, number 5. Number 5, distributive law. If A, B and C, if A, B and C are any three sets, then number 1, A union bracket start B intersection C is equal to A union B intersection A union C. A union bracket start B intersection C is equal to A union B intersection A union C. Number 2, A intersection B union C is equal to A intersection B union A intersection C. If A, B and C are any three sets, then A union B intersection C is equal to A union B intersection A union C. Next, number 2, A intersection bracket start B union C is equal to A intersection B union A intersection C. Number 6, De Morgan's law. If A and B are any two sets, if A and B are any two sets, then number 1, A union B whole complement of A union B is equal to complement of A intersection complement of B. Number 2, complement of A intersection B is equal to complement of A union complement of B. Remember these points, most important. The Morgan's law, if A and B are any two sets, then complement of A union B is equal to complement of A intersection complement of B. Next, number 2, complement of A intersection B is equal to complement of A union complement of B. For example, A is equal to 1, 2 and the set B is equal to 2, 3. Left hand side, A union B is equal to 1, 2, 3. Use an universal set 1, 2, 3, 4, 5. Next, therefore, A union B, complement of A union B is equal to 4, 5. Next, right hand side, complement of A is equal to 3, 4, 5. Next, complement of B is equal to 1, 4, 5. Therefore, complement of A intersection complement of B is equal to complement of A intersection complement of B. The common elements are 4, 5. 4, 5. Therefore, the left hand side is equal to right hand side. Complement of A union B is equal to complement of A intersection complement of B, because this is equal to this. Next, remember, formula to solve practical problems on union and intersection of sets, of sets. Formula to solve practical problems on union and intersection of sets. Number 1, let A, B and C be any three sets, be any finite sets Finite sets means the total number of elements are finite sets, and U be the finite universal sets, then let A, B and C be any finite sets and U be the finite universal set. Then number 1, n of A union B is equal to n of A plus n of B minus n of A intersection B. Next, number 2, if n of A intersection B is equal to 5, that means number of A intersection B is equal to 5. 5 means null set. Then there are no common elements. Then n of A union B is equal to n of A plus n of B. Next, number 3, n of A defines B. N of A defines B is equal to n of A minus n of A intersection B. Number 4, n of A union B union C. This is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A union B union C. Remember these formulas. N of A and B, A, B and C are any three finite sets and U be the finite inversal set, then n of A union B is equal to n of A plus n of B minus n of A intersection B. Number 2, if n of A intersection B is equal to 5 is null set, then n of A union B is equal to n of A plus n of B. Next, number 3, n of A defines B is equal to n of A minus n of A intersection B. The last number, n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Thank you.